Okay, Bergson and the Holographic Theory of Mind. Back again, ongoing series, part 30. We'll be talking about David Chalmers, the author of the famous hard problem, and thus the hard problem and the easy problems he identified in consciousness. The entire misdirect with respect to Qualia that he directed, and the image of the external world, and just when was the extinction event. We'll find that the easy problems he identified are, in general, tougher than hard. And we'll look at the illusion of functional explanation, which is a mode of explanation that he champions as though it has some reality. It has none. Dynamics, the notion of a real concrete dynamics that the brain might assume, missing and more missing. A little visit to Bergson, of course, and the key to a dynamical model. And then what I'll call the singularity of misunderstanding, referencing Chalmers' backing of the singularity, and all of the above contributing to a massive misunderstanding of the subject. So in this series, I've noticed something about Dr. Chalmers a few times, namely about the hard problem. While a service, calling attention to a huge problem in AI, namely that computers in and of themselves have a glaring lack in explaining consciousness, there was also a disservice, a misdirection. We'll touch this again here. It's critical. It starts several other balls rolling in the wrong direction, particularly an ubiquitously quoted distinction of Dr. C, namely the hard versus the easy problems. As we'll see, the easy ones are worse than the hard problems, way worse. But this miscategorization of hard and easy also supports any credibility for AI's singularity and the myth thereof. Finally, all this relates to a blind spot that Dr. C has had and still does with respect to the need for concrete dynamics. And this is a profound problem and gap and leap that has to be taken by many a theorist. In 1995, then, in the Journal of Consciousness Studies, Dr. C's article appeared, titled Facing Up to the Problem of Consciousness. In it, he distinguished between the hard problem and the easy problems. The easy problems, the ability to discriminate, categorize, and react to environmental stimuli, the integration of information by a cognitive system, the reportability of mental states, the ability of a system to access its own internal states, the focus of attention, the deliberate control of behavior, the difference between wakefulness and sleep. To quote him, there is no real issue about whether these phenomena can be explained scientifically. All of them are straightforwardly vulnerable to explanation in terms of computational or neural mechanisms. And all my quotes from him will be coming from the 1995 article. So right, we'll be right back on these. We'll be back in a bit. Then there's the hard problem. The really hard problem of consciousness is the problem of experience, he said. When we think and perceive, there is a whir of information processing, but there is also a subjective aspect. As Nagel has put it, there is something it is like to be a conscious organism. The subjective aspect is experience. When we see, for example, we experience visual sensations, the quality of redness, the experience of dark and light, the quality of depth in a visual field. Other experiences go along with perception in different modalities, the sound of a clarinet, the smell of mothballs. And further on he says, why doesn't all this information processing go on in the dark, free of any inner feel? In other words, in a dark, quiet brain. Why is it that when electromagnetic waveforms impinge on a retina and are discriminated and categorized by a visual system, this discrimination and categorization is experienced as a sensation of vivid red, or purple, or blue, or green, or a butterfly. This was the beginning of the emphasis on explaining the origin of qualia as the problem of consciousness, the hard problem. Though Chalmers never uses the term qualia, believe it or not, in the article. Nevertheless, the standard list of qualia examples is there. The felt quality of redness, the smell of mothballs, the sound of a clarinet, the experience of dark and light. All notice, for the most part, static, not dynamically changing. I'm quite sure that Dr. C thought and thinks the image of the external world is, to invoke the previous quote, explainable in terms of computational or neural mechanisms. Just not its colors, just not its qualia, just not what it is like. This was the misdirect. I noted part 1 right off the bat, a few other parts. It is the image that is the problem. The image is filled with forms. We've seen that form is qualitative. It is defined over flow fields. The features, edges, vertices, for example, are simply invariants, that is, sharp discontinuities at the junctures over flows. A form can qualitatively change. The example I've been using of the strobed wire cube. At a non-integral multiple of its symmetry period, it becomes a wobbly, plastically changing, non-rigid, not a cube. It has to be strobed in phase with its symmetry period. Rotates, maps onto itself 4 times a revolution. But that is a quality difference. The form changes quality. Again, rotating too fast, a rigid ellipse. Because of the velocity vectors that actually define its perimeter, rotating too fast, it becomes a non-rigid floppy ellipse, a qualitative change. And then we saw form is an optimal specification given the nature of the flow of time. Because given the constant flow, constant change of time, no matter how minute the interval in a constant change, no value can be precisely determined. A fixed value does not exist. This is a cosmic trade-off, a feature of the universe, uncertainty for constant change. Once you have fixedness, you have frozenness, and you have a frozen universe at a state that can never change again. We discussed all this. We noted Valerie Hardcastle's examples of qualia. The conductor waving her hands, the musicians concentrating, the patrons shifting in their seats, the curtains gently and ever so slightly waving. In other words, her entire experience in that symphony to which she's referring, that is the image of the symphony, the players, the conductor, the instruments, the patrons, the audience, all dynamically transforming forms. And form is a function of the scale of time imposed by the dynamics of the brain. At our normal scale, we have buzzing flies, wings beating at 200 beats per second, perceived as a blur. But increase the energy state of the body, the brain, and its underlying neurochemical processes. We could have a heron-like fly, slowly flapping its wings. Increase the energy state yet more. We have a shimmering, oscillating, crystalline being that the fly actually is. Increase it yet more. The fly becomes an ensemble or cloud of electrons. All of these are qualitative changes. This is a set of qualitative changes as we descend scales. These forms are qualities, just like the gently waving curtains versus violently swinging curtains. So it's a hard problem. To deny the image on the whole is the problem. The image is fully populated with the forms, dynamic forms, changing forms, all at a scale of time, all qualities. Even a static cube sitting on the desk. The eyes are in constant motion over it via the saccades. If the image of the cube is fixed on the retina, it fades. Motion is required. Why is that? Because the brain lives in a different metaphysic, where there's constant change, and there cannot be determinate values. You have to account for, then, gently swinging curtains, gyrating leaves, wobbly cubes, the infinite qualities of motions in our image of the world. And motion is integrally one with time. But time, for the hard problem theorist, does not exist. For example, Hardcastle's examples literally begged for a treatment of time. Nope, not even close. The examples occur in page 1. Somewhere down the road in the book, you see time mentioned only to be dismissed as a problem. So time is non-existent in the hard problem theoretical world. So from whence does the problem of qualia derive? The core of the hard problem is the classic metaphysic. The metaphysic is itself a conception of space. In fact, it's an abstract space. It consists, so to speak, of a field, a continuum that's infinitely divisible. As Bergson called it, it's in actuality a principle of infinite divisibility. We can divide it at will to the smallest points possible. It's like, as he said, it's a mental grid which we place beneath concrete extensity. The extensity stretching out before us in the real world, the tables, the chairs, the floors, in the kitchen where I'm sitting, and whose meshes we shrink to points. And so we end with the continuum of positions. And then we conceive of motion as proceeding from point to point across the continuum. And then each point occupied by the object, so to speak, momentarily, is also an instant of time. So time becomes simply the fourth dimension of this abstract space. It's equally part of the abstract space. It's just this series of discrete instants, each instant itself being infinitely divisible. And the limit of this operation is a mathematical point with no beginning and no end, thus no change. No change is possible. It's a static instant. And the implication is that if you truly have a static instant, such that you could have a determinate value, by the way, nevertheless, you have a frozen instant, and no change is possible. You have a frozen universe. Now, it's a homogeneous continuum as well, precisely because of this. It's a continuum of mathematical points / instants, where each instant disappears as the next arrives, or taken as a whole across space, an instant of instantaneous space. Space 1. Space 1 disappears as the next space 2, next block arrives. Space 2 disappears as the next instantaneous space, space 3, arrives. So you never have more than a block, shall we say, of instantaneous space at one moment in time, then the next, each disappearing as the next arrives. No quality is possible then within this abstract, homogeneous continuum of mathematical points / instants. No gently waving curtains, no patron shifting, no cubes wobbling, no colors and no sounds, no qualia, nothing. Within the brain, equally so. The brain is, in this classic metaphysic, has to be considered part of the continuum, the homogeneous continuum. No qualities possible within the brain either. This abstract space is the basis of computation. It's the basis of calculus. It's the basis of our science. It's the projection frame through which we view reality. And thus, it's the projection frame through which the hard problem is viewed. Given this homogeneous nature, then all quality must arise outside the homogeneous abstract space in which we all dwell, in which the brain dwells, in some other space, some other dimension, be it the mental, anywhere but in the abstract homogeneous continuum. So Bergson on the origin of the image of the external world. We'll do it in one slide. 1896, Matter and Memory. He postulated that the universe is a holographic field. 80 years before, Bohm argued the same thing, 50 years before the invention of holography. And he postulated, in essence, that the brain forms a very concrete, modulated reconstructive wave passing through this field. A little picture of holography up there on the right. We have a reconstructive wave passing through the hologram, the holographic plate. It's a frequency 1, that reconstructive wave, and therefore is bringing or specifying a virtual image of a cube to the viewer. We modulate that wave to frequency 2, and we pull out other information, specify other information, other recorded wavefronts on that plate. Frequency 2 brings out the cup. We can continue modulating that wave for different things. So the brain forms the modulated reconstructive wave within a holographic field. And the brain then, this brain/wave, is specific to a source or sources within the field. And by this now an image of an aspect of the field. For example, a coffee cup. The underlying dynamics of the brain impose a scale of time. The image is specified at a scale of time. A buzzing fly versus a heron-like fly, depending on the energy state of the dynamics underlying that reconstructive wave, which is the brain. The image is precisely where it says it is, in the field, external to the body. That is, this is direct perception, as Gibson also argued. The time transformation of the field is indivisible, as opposed to the classic metaphysic. There are no discrete instants, for each just previous instant is falling into the non-existence of the past, and thus having to be stored in the always present brain, as the classic metaphysic demands. For the only thing that's present is the present instant, which in effect, by the way, is, as we saw, a mathematical point. So with the indivisibility of time, the time transformation of the holographic field, form can now be quality. This is not a homogeneous field. This is a heterogeneous field. We're specifying qualities within the field. And this motion, indivisible, forms a primary memory then, primary memory property of the field's transformation. The dynamically changing image, the coffee cup, for example, and a stirring spoon, is thus a specification of a past extent of the field's transformation. We're leaving out here Bergson's treatment of subject and object, essential to this, and several other things, but this is sufficient. So 5 years forward from 1995 in Mr. Chalmers, Dr. Chalmers, my discussion of Bergson was published not long after, in 2000, in the same journal, Journal of Consciousness Studies, titled Bergson, Perception and Gibson. Now, I did not emphasize, nor did I neglect the problem of qualia. As I looked through it, I didn't use that term. I didn't use the word either. Rather, I was emphasizing Bergson's solution to the origin of the image of the external world that we just saw. The brain is a holographic wave within a reconstructed wave within a holographic field. That qualia was naturally implied. This was obvious to me, because I was talking about all the qualities, such as buzzing flies, heron-like flies, etc., already then. Nope, was not obvious. I started to wonder, why was the significance of Bergson not seen? I should have gotten a little bit of a hint. In 2004, I published an article titled On Time, Memory, and Dynamic Form in Consciousness and Cognition. The reviewer was asked, while they were in the review process, what time had to do with qualia, which was an amazing blind spot. fundamental answer is, if you cannot even bind two instants together, as per the classic metaphysic, you can have no qualities, period. You have to have this indivisibility of motion, as Bergson postulated. I wish at the time I had been more aware of Valerie Hardcastle's beautiful examples as well, which basically easily show that the image is nothing but dynamic forms. You have to explain the image itself. But for a few years, to about 2007, I participated in an online forum under the auspices of JCS. And in discussing various articles that were appearing in JCS trying to solve the hard problem, I would take my shot at trying to re-explain Bergson. And one of the discussants told me roughly this: if you want an explanation of how a system might specify or create or generate an image, of course we have all sorts of mechanical systems that can generate images. So one might propose any of them as a model, then try to match circuitry in the brain. But as is well known, that doesn't even address the hard problem, which is specifically about why that image is like something to us, with its particular phenomenal properties. So in other words, by the way, this is an exact quote, He was visualizing, for example, computer systems that generate images. And all we have to do is match the circuitry to the brain. But that's not the problem. It's the phenomenal aspect. It's why something is like something to us. That's when I knew we were in trouble. The hard problem is not understood. It has been so distorted so badly toward qualia, to what is like, what it is like, and to the idea that forms or images are computable, that a solution to the origin of the image cannot be seen as the answer. Consider the absurdity of the statement with respect to images via computer. What is an image in a computer? Well, it's an array of bits over there on the right, where 3 sets of 8 bits are an RGB code for the color of a pixel. So I've taken the first row of bits, 8 bits, 3 sets of 8 bits. The first is an RGB code of 250, which is red. The second is a 128, which is a little bit orangish, and the third is 114, which is blue. All that together make the color salmon. And then you need a position code for where that pixel is going to reside. So you get the pixel color, and then you just need a position code. It could be just its position in the array of where that little pixel is going to land, that salmon color. So put all this together, that a whole array of pixels and their colors there, and it's a picture, it's an image, but only because we attribute this to this. We know that it can be projected out there on a screen and become a salmon. But it's an attribution. This is what we have in the computer. What would be a dynamically changing image, like stirring the coffee? Well, it'd be a series of such arrays, such instantaneous arrays. Next one, then the next one, then the next one, then the next one. This is scaleless with respect to time. One can run these arrays as quickly or as slowly as one feels. It does not change the projection of the image, whether it be a salmon, whether it be the coffee stirring, except it would in human perception. It means nothing to the computer, to the inner structure. There is no continuity. Again, the arrays, one appears, then the next one disappears, the next one comes, then disappears as the next one comes. There is no continuity, again, except to human perception, not to the computer. This would not handle velocity flows. It would not handle the strobed rotating cube suddenly becoming a wobbly knot cube. Who is looking at it? Not the computer. It is a code. How does code equivalence to the salmon or stirring coffee? remember the coding problem, which I think we hit in part 1. The coding problem, also known in academic parlance as the problem of representation. This is the difficulty. The coding is more clear. You must know the domain the code maps to. 3 dots can be an S, Morse code, 3 blind mice, a nose. To use a code, it would imply you already know the domain. That is, you know the external world. And yet the code is precisely supposed to be the instrument by which you know the external world. So we have a complete logical contradiction, a logical impossibility in using a code. To say this is an image then, and we just have to add what it is like, this is absurd. Now, the forum guy's theory, just for grins here, he said, there is no reason for a physically instantiated image. There is no image as such, only the processes occurring in the mind. The brain does not generate an image. It transmits information to the conscious mind. So I beg to disagree. There is indeed reason for a physically instantiated image. Else you're going to have no scientific theory. Yes, you may have to redefine the physical as Bergson's temporal metaphysic is going to do. But at least Bergson gives a device, the outlines framework for a device, such that we can now explain the instantiation, the specification of an image. But he says only the processes occurring in the mind. Now he's a Whiteheadian person, and so he's thinking this is a process. And somehow he thinks that Bergson's image, which is, I've stressed over and over, dynamics, dynamically changing form, is somehow not a process occurring in the mind. In fact, he told me that Whitehead was a very, very smart person, and this was Whitehead's theory. And I've always thought this was interesting, that even though obviously I'm only explaining Bergson and saying such, this goes right over people's heads. Such a statement that he made would be equivalent to saying, well, Mr. Bergson, you should see Mr. Whitehead because he's very, very smart. And then finally we get to this sentence: the brain does not generate an image, it transmits information to the conscious mind. Well, what does this mean? What is the information being transmitted to the conscious mind? Is it the bits in that array? Then what is the conscious mind such that it can now decode the bits into the external world, whether it be 3 blind mice, Da Vinci's nose, or an S, or the salmon, or the coffee? What are you relying on consciousness to explain? Well, you've just put everything into the mystical, into the mental, into a metaphysical realm somewhere that science can approach. So the attributes of the image. It has a scale of time, as we've seen, a buzzing fly versus a heron-like fly slowly flapping its wings. This is an integral aspect of its quality. It has a time extent. We perceive rotating cubes or stirring spoons. This too underlies the quality of the image. It is a reflection of action, or as Bergson put it, it is virtual action. We are seeing how we can grasp the spinning cube versus the slowly rotating cube. It is filled with dynamic forms, to include, for example, facial flow fields. These are qualities. Nothing in this image is computable, and it is external to the body. All these must be addressed simultaneously, in addition to the problem of the homunculus, for it does no good to have a little man, a hidden homunculus, viewing the image, as so many theories surreptitiously do. But this is the great problem of subject and object, and I do not believe this problem even exists for Dr. C. The history of the theory of perception has been the struggle to explain the origin of the image of the external world. Folks that took heavy shots at this were Pythagoras, Euclid, Democritus, Epicurus, Chrysippus, Galen, Plotinus, Alhazen. I'm missing Penn, but then Da Vinci, Kepler, Descartes, Locke, Berkeley, Barclay, Condillac, Hume, Brown missing, J.S. Mill, John Stuart Mill, Helmholtz, James, well, the real James, William James, Mach, Bergson, and I end with Gibson, but others too. This history is nicely described in Thomas Lombardo's book, 1987, The Reciprocity of Receiver and Environment. I happen to have access to Tom Lombardo's thesis at the University of Minnesota. He was a student of one of my advisors, Bob Shaw. And this was an incredible exposition of the history of philosophy and where Gibson, or history of the philosophy of perception and where Gibson fit in it. Highly recommended. Now, all took as a given that the image is qualitative, external, consisting of objects, forms, surfaces, colors, and flows. Yes, they had different ideas as to how to explain it. The question is, would all these guys now accept this? That is, the problem is not the origin of the image, as they thought, of the external world, but merely the origin of qualia. So when did the image go extinct? What happened? What happened is the computer and Dr. C and the formulation of the hard problem. But the problem has not changed, despite the fact that the word image never appears in the literature on the hard problem / qualia today. And I've done this search. It's amazing. The image does not appear. In fact, it does not appear in Chalmers' 1996 book either. We can perhaps assign to Nagel, Thomas Nagel, 1974, the what it is like formulation. Chalmers referenced it in 1995. But it seems to me only someone very unfamiliar with the problem of perception in its history could have cast the problem solely in this narrow band. Like, where's the qualia? Where's the beef? Chalmers, I suspect, fit the above. He had to be pretty unfamiliar with the history of perception theory. As I noted, one can search the literature on the hard problem and qualia for the word image. You literally cannot find it. But the problem, solely in terms of qualia, has become the sole focus for the day's theorist. So the problem is so misstated, theorists wouldn't see a solution if it fell on them like the proverbial piano from a 10-story building. And this has consequences. Consequences. Let's take one of the easy problems. The integration of information by a cognitive system. For Chalmers, the easy problems are easy precisely because they concern the explanation of cognitive abilities and functions. To explain a cognitive function, we need only specify a mechanism that can perform the function. So this begins a great theme in Chalmers, functional explanation. Now, what is meant by integration is vague, but take just 3 examples of cognitive functions we've seen in earlier parts. The achievement of concrete operations, number 6. The achievement of explicit memory, and number 5. Penrose and his mathematical proofs, also number 6, and number 28. So, first, operational thought, Piaget, in The Child's Conception of Movement and Speed in 1946. You have children aged 3 to 7, and a little experiment. We put 3 beads strung on a wire, call them ABC, different colors, and they can be fitted into a small cylindrical tunnel. And the beads are run into the tunnel, and the tunnel is semi-rotated 180 degrees from 1 to n times. So we're going to rotate our tunnel, and they come out in the opposite order for just a simple 180-degree rotation. Now, at some point, the child can imagine the result of 3 to 4 of these half turns, but not in general the odd-even rule. Because we know in our brilliant cognitive development now that if you semi-rotate the tunnel twice, another 360, the order remains unchanged, or 4 times, or 6 times. But an odd number of turns changes the order, like we just saw. 1 turn, 3 turns, the order changes. So the children can imagine what happens with 3 to 4 of these half turns. 1 turn, order changes. 2 turns, it's back to where it was. 3 turns, order changes. 4 turns, back to where it was. And quotes, Piaget says, but since the child, upon each half turn, endeavors to follow the inversion in every detail in his thoughts, he only gradually manages accurately to forecast the result of 3, 4, 5 half turns. Once this game of visualizing the objects in alternation is set in train, he finally discovers that upon each half turn the order changes once more. Only the fact that up to this upper limit, the subject continues to rely on visualizing intuitively and therefore needs to image one by one the half turn is proved because he is lost when a jump is made from one number of half turns to any other. So if you ask what happens with 1 turn, he can do it. Now when you say what happens with 5 turns, he can't do it. If he gets to 2 turns, now you ask what happens with 4 turns, can't do it. So after this gradual perception of a higher order invariant, that is the oscillation of order, defined over events of semi-rotations, there's the oscillation of the order with each half turn, there comes a point where the child can easily answer the ultimate question with respect to the odd-even rule for the resultant order for any n turns. Piaget's explanation, describing the operational character of thought, is foundational to his theory. Quote, operations, one might say, are nothing other than the articulated intuitions, rendered adaptable and completely reversible, since they are emptied of their visual content and survive as pure intention. In other words, operations come into being in their pure state when there is sufficient schematization. Thus, instead of demanding actual representation, each inversion will be conceived as a potential representation, like the outline for an experiment to be performed, but which is not useful to follow to the letter, even in the form of performing it mentally. The lesson that the abstract is built upon the concrete. That is, the schematization is the gradual paring down, abstracting, skeletonizing of the very concrete image. The abstract operations then only emerge after a long dynamic developmental trajectory, taking from roughly 3 to 4 years, which involves imaging events. So this is supposed to be an easy problem to functionally explain. Move on. So take the same problem, this time Piaget plus Penrose. And Penrose's example of non-computational thought. Again, the example we've referred to a few times now. His visual proof of a computation that does not halt, where he takes successive hexagonal numbers, folds the hexagonal number into a 3-sided structure, or 3-sided cube, and stacks it over the previous cube, always making a cube, or a cubical number. And thus we have an ever-growing cube, larger and larger cube, always preserving cubicalness. This is dynamic transformations of imagery. It's dynamic over a continuous extent of time, over which invariance emerges, whether it be the oscillation of order, as in Piaget and his rotations, or the preservation of 3-sidedness and cubicalness as we fold and stack in this particular instance. So a continuity of memory is required. One cannot have state after state where each state preceding state disappears, such there's never more than one single state. One has to have continuity of memory. This is required to perceive the global transformation and thus the invariance. This absolutely then requires consciousness, which is to say a device, quote unquote, i.e. a brain, integrally embedded, participating in the indivisible transformation of the universal field. Its dynamics, its operations have to be integrally embedded within this indivisible transformation. And this is no different than what is required involved in Piaget. And note, well, is this easy? No, not even close. And note, this is absolutely involved in common sense knowledge. Whether we're rotating pencils and forming them into arrows, or using them, forming them, placing them such that they're handles for little axes, or whatever, this form of dynamic transformation, whether it be stacking, whether it be rotating, and more, all basic transformations are necessary in common sense knowledge. The redoubt that's resisted AI ever since they first thought of it. Chalmers, however, says this: non-algorithmic processing, for example, is put forward by Penrose because of the role it might play in the process of conscious mathematical insight. In other words, he's talking about the non-computational thought, as described in the stacking of the cubes. Even if the arguments succeed and an account of non-algorithmic processing in the human brain is given, it will still only be an account of the functions involved in mathematical reasoning and the like. Whether non-algorithmic or algorithmic process, the question is left unanswered. Why should this process give rise to experience? In answering this question, there is no special role for non-algorithmic processing. Wrong. Totally wrong. Not why should it give rise to experience. This is the manipulation of experience. The experience coming from our four-dimensional being. When the child is trying to imagine the tunnels rotating, he's relying on images from his past, or when stacking cubes, or in the little example I like to give from Wertheimer on the bottom there, where a little 5-year-old was given a parallelogram, asked to compute the area, and she simply turned it into a cylinder. Simply folded it into a cylinder, asked for a scissors to cut it so she could make a rectangle. An incredibly neat dynamic transformation of imagery. So whence does this come? It comes from our playing with blocks, tunnels, everything in four-dimensional being. It's from this that the images derive. And this process, the imagining of the tunnels rotating, the cubes stacking, the cylinder being folded, forming into a cylinder and being cut, is all taking place over an indivisible, continuous flow, such that these global transformations can be perceived. This is non-algorithmic processing. Easy? Absurd. This is a complete misunderstanding on Chalmers' part. But worse, all this relies on explicit memory. Explicit memory, as Piaget described it, the ability to localize events in time, integrally related to the ability to symbolize, and the development of a base complex of concepts, causality, object, space, and time. This requires a dynamic developmental trajectory covering the first 2 years of life. In Piaget's ultimate example of the emergence of symbolizing simultaneously with explicit memory, conscious localization of an event in the past, was little Jacqueline seeing a piece of grass. Homer's playing Jacqueline here, and remembering playing with the grasshopper. 2 days earlier with her cousin. The grass becomes a symbol, now for an event localized in the past. This is a dynamic developmental trajectory taking 2 years. It needs articulated simultaneity, as I've argued, such that it's a dynamical state, such that the present event can simultaneously redintegrate and correlate with a past event. Weisskranz past by present correlation, supporting conscious explicit memory of the past event. And of course, in reality, we're dealing with a 4-dimensional being, and that entire 4th dimension of his experience, Ishira's experience. And recall, it is this articulated simultaneity that is required for true analogical thought. Easy? Absurd. So this is what I'll call Chalmers' functional illusion. To quote again, if we show how a neural or computational mechanism does the job, we've explained learning. We can say the same for other cognitive phenomena, such as perception, memory, and language. This is a giant if. Perception. With no theory of the image of the external world, you've explained nothing. You have no theory of experience. Memory. Given the above lack, you don't know what experience is. You have no clue what you're storing. You have no clue how to store experience. Language. It's built upon both perception and memory. You have no clue. You might as well throw cognition in here, which we've just been looking at. To quote, sometimes the relevant functions need to be characterized quite subtly, but it is clear that insofar as cognitive science explains these phenomena at all, it does so by explaining the performance of functions. And given a functional, quote, explanation, quote, there may still remain a further unanswered question. Why is the performance of these functions accompanied by experience? A simple explanation of the functions leaves this question open. But as we've seen, the functional explanations are giant illusions. You're not even coming close to Piaget, Penrose, Wertheimer, the explicit. You must deal at base with consciousness, time, the image, imagery, experience, to have an explanation at all. Functional explanation in the Chalmers world is an utter, complete, beyond belief illusion. Let's take one more easy. Just one more. You could go through virtually all of the easy problems and tear them apart. We'll just take voluntary action, which he calls the deliberate control of behavior. Right. Remember Scott Aronson noting the standard opinion of the problem of whether P equal NP, namely as the central unsolved question in computer science? And his response to this, that's a comical understatement. P versus NP is one of the deepest questions that human beings have ever asked. Well, triple this for voluntary action. Comical understatement to call this an easy problem. We've touched on this in number 9 in free will, in number 26, the memory of spiders. It involves how images bring about action in the brain and the body. That is, how 4D being acts as a whole in the physical world. It involves Bergson's notion of dynamic schemes in the relation to Lashley, to syntax, and the atemporal idea, bringing about the action, the very nature of the psychophysical field in which we are embedded. Thus, why I was driven to explore notions of the ether and the question of what is a field in numbers 18 and number 22. The possibility of fields bringing about behavior, spider webs, bird migration, the problem of instinct. All this is involved. I regard Bergson as struggling here as well. We're talking about a profound problem. The deliberate control of behavior, which I can easily construe as how we will to move our finger. Easy? Enough said. We're dealing with the whole problem with the very nature of the field in which we're embedded. Wait on enough said. I've got to add, Chalmers' hard versus easy distinction is still quoted extensively today. It is, with some exceptions, extremely misleading in trivial cases. But worse, it is an illusion. It gives credence to this, that computational explanations are valid. We just need to explain the pesky accompanied phenomenal consciousness, qualia field consciousness. That is, it gives credence to the utterly wrong path on which AI, deep learning, cognitive science is traveling. Fast forward into 2014. At a TED Talk, we see the same principle yet, that is the misperception of the worth of functional explanation, as he conceives it. His opening statement, right now, you have a movie playing inside your head. It's an amazing multi-track movie. I've got to stop here for a second because I had a commenter on my Bohm discussion of number 17 who thought that I had completely done injustice to Bohm and his understanding of Gibson. So I went back and reread that piece of Bohm on Gibson and was struck, of course, by the fact that Bohm continuously used the phrase inner show, the inner show going on. Remembering my critique of Bohm that pointed out that he never made the move that Bergson did, where the brain became a reconstructive way of specifying an image external to the body. So this phrase inner show, of course, Gibson would not have been caught dead saying. But moving on. Chalmers says, why is it that all that physical processing in the brain should be accompanied by consciousness at all? Why is there an inner subjective movie? Faced with a phenomenon like this, we need radical new ideas. We certainly do. So Dr. C's two main ideas. Consciousness is fundamental. It's like mass, like charge in physics theory, a basic building block of theory. And consciousness is universal. Every system might have some degree of consciousness. This is called Penn psychism, as he notes. Dogs, mice, flies, microbes, even a photon, all have some form of consciousness. And he goes on, a way to link fundamental laws of consciousness to physical processing is to link this with information. Wherever there is information processing, there is consciousness. Complex information processing equals complex consciousness. Simple information processing, simple consciousness. Human brain, an incredible amount of integration, big consciousness. Mouse, not so much. Go down, worms, microbes, less consciousness. Truth is, Bergson argued all this in 1896. The degree of consciousness is a function of the complexity of possible action. Given perception is virtual action. Now, Dr. C noted Tononi's mathematical measure, phi, of information integration and consciousness. He's got some sort of mathematical information of integrating information and therefore getting degrees of consciousness. And Dr. C notes that this is the leading theory in the science of consciousness. And it's really nice because it fits on a t-shirt. So I thought, well, we definitely need a Bergson t-shirt. So this is my first stab at a Bergson t-shirt because you'd have a choice of 3 cups. Of course, the brain is a reconstructive way of specifying the cups, and a choice of 2 beans. And it'd be $19.95 plus tax, and not available in, well, anywhere right now. But if you're going for t-shirts, we could do one. As noted before, however, Gibson would dispute the very definition of information as currently held and as Chalmers is referring to it. He goes on, what about AI? the movie Her, with the character Samantha. I think she was just a computer. She certainly has complicated information integration. So the answer is very likely yes, she is conscious. This is the critical problem of panpsychism. It has no capabilities of itself to explain the image of the external world. Bergson offered the solution. The brain is a reconstructive wave passing through in effect, panpsychic holographic field. Remember, at the null scale, the holographic field is, as Bergson called it, pure perception. And the reconstructive wave specifying a subset as an image. This is how you get experience. This is how you get the image of the external world, which is our experience. Panpsychism has no capability whatsoever to do this. So, Mr. Rat here, pay attention, is actually going to make a relevant comment. The robot is not a reconstructive wave. Good observation, Mr. Rat. Dr. C says he's not confident of the panpsychic principle. There's the aggregation problem, how the little bits aggregate or add up to form the kind of consciousness we know and love. That is, how do you add up a whole bunch of photons that are conscious and get a buzzing fly or falling leaves? You don't. It's the aggregation problem. Bergson showed you how. That is, again, a subset specified at a scale of time, because the buzzing fly can be a heron fly. Or a pile of electrons. How do the bits aggregate to do one or the other? Good problem. He doesn't even think about this. Bergson avoided the aggregation problem. You'd think this would catch a panpsychic's attention. Nope. "2017, fast forwarding more. A discussion panel, what machines can't do. Chalmers says, we know that a machine can do everything a brain can do, because the brain is a machine. And then he says, I still think there's a pretty good reason for the brain can be simulated, because the brain is still a physical system following physical laws that we know can be simulated to an arbitrary degrees of accuracy. Therefore, the brain could be simulated or emulated by an artificial machine. In principle, you could simulate every physical process in the brain in an artificial program machine that would then deliver the input-output behavior of the human brain. Note how he subtly rubber bands to a computing machine. We've seen this before. Back to 1996. In The Conscious Mind, he described the thought experiment. He had a neural net, and he gradually substituted a daemon for each neuron in a neural net. Each daemon merely noted the input to the neuron on a sheet of paper, using the weighting algorithm to determine the output, and pass the output figure to the next daemon. Ultimately, all the daemons were replaced by one daemon, racing around, writing inputs and outputs on myriad sheets of paper. This pure symbolic notation process, argued Chalmers, was perfectly sufficient to, quote, maintaining the causal relations, quote, needed for the net, that is, its computational capacity. I wonder how Searle would argue with that, because causal relations. So it's abstract computations based in the abstract space, not dynamics, not real concrete dynamics. That means all to Chalmers. That the net might be part of a humming, vibrating, dynamical system of forces, charge, etc., fields, is not considered. His causal connections are pure abstractions. That is actual dynamics, physics, forces, etc., that is required for consciousness, for cognition. That it might be such. This means absolutely nothing to Dr. C. Remember, a simulation of an AC or DC motor runs not one Christmas light. You need concrete dynamics. Chalmers is entirely stuck and the classic metaphysic. As is the entire AI and mind uploading literature, for example, too, for which actual dynamics means zero. We just download abstract information. The dynamical system that the brain might be, meaningless. This blind spot related dynamics is kind of in general is a toughie. Curing the blind spot involves a difficulty, a leap. I just saw a Google talk by Ned Block, titled Why AI Approaches Won't Work for Consciousness. And he's arguing that AI functional approaches won't explain phenomenal consciousness. It's sort of actually the same functional explanation versus phenomenal explanation that Chalmers goes with. But he understood the simulation problem with respect to the brain. Someone asked him, "What does simulation work?" He says one common point: the simulation of a rainstorm isn't wet. A simulation of a conscious being may not be conscious. Beyond this, he was drawing a blank. He said, quote, "This goes back to the issue. That could be true, that consciousness depends on something like in the neural processes, some kind of analog thing. Signals in neurons are electrical, but communication across the neurons is chemical, across the synapse. Maybe that is part of what is needed for consciousness. People have made artificial synapses, but maybe they must use neurotransmitters to have genuine consequences." So do you see the issue here? There's no real clue what the dynamics of the brain as currently understood could actually be doing. Why neurotransmitters, why neural processes should have anything to do. Utterly clueless. Bergson gives the only guide here. Whatever you choose to look at, say EM fields, taken in total, must comprise a device concrete enough to be a reconstructive wave within the holographic field. Then you can have perception, then you can have experience, then you've got four-dimensional being, etc. Now you've got the ball rolling. This is an hypothesis that's worth following as to the contribution of real dynamics. Just too much, apparently. Now, Dr. C noted that machines are at a very low level currently, animal level, perhaps not even animal. The famous Go champion now, AlphaGo program, certainly experiences nothing. There's nothing it is like, quote unquote, to win at Go as far as AlphaGo goes, as opposed to the rat, who's clearly ticked off at losing. It does not exult over winning or contemplate the board, the machine. So the moderator asked, are you pursuing artificial intelligence or artificial consciousness? Can you have one without the other? Now, I note up there Hillary Lawson, who is sponsoring this discussion, was not too happy because he doesn't like what Chalmers is saying, but he doesn't have a real, powerful argument against Chalmers. But with respect to this question, Chalmers says, all these words are horribly ambiguous. I use consciousness for the subjective part. I think it is useful to use intelligence for the behavioral part, for the operational part. If we are worried about machines taking over the world in a way that it's going to matter, it's the behavior. If the machines are going to beat us in a machine war, it won't matter if they're unconscious zombies. It will be the intelligence, the behavior that will make a difference. So you can agree with that, yes. If they're that intelligent that they can just, shoot us in seconds with their artificial aimers, yes, there's going to be a problem. But, says Chalmers, but if you've opened the question of how far intelligence can go without consciousness, I believe that if machines are intelligent enough to behave as us, flexible as us, they will be conscious. Interesting. So, repeating that quote for a second, you've opened the question of how far intelligence can go without consciousness. And he says, if machines are intelligent enough to behave as us, flexible as us, they will be conscious. But why? Because we've just said that functional explanation is fully sufficient to explain intelligence. So the secret ingredient that experience, consciousness adds, must have a whole lot more power than just a kind of epiphenomenon going along with the functional mechanisms. So why? We've come full circle to the fundamental nature of cognition, which is, yes, harder, that is, not easy, harder than Dr. C has ever brought himself to imagine. Nevertheless, he had stated earlier in this discussion, better than 50% chance of human-level AI. Human-level AI. By the end of this century, I think I'd stand by that. But I don't know what he's standing by, because he clearly has no conception of what cognition and human thought actually involve. His view of it is utterly insufficient. So that 50% chance is a completely illusory guesstimate. So we'll just say right. So a postscript. We'll call this the web of 1995. Going back to 1995. Reductive methods are successful in most domains because what needs explaining in those domains are structures and functions, our good old functions. And these are the kind of thing that a physical account can entail. When it comes to a problem over and above the explanation of structures and functions, these methods are impotent. Warning, all here is going to depend and depends on what is physical. And I've noted Bergson's temporal metaphysic implies a new definition. So going on, this might seem reminiscent of the vitalist claim that no physical account could explain life. But the cases are disanalogous. What drove vitalist skepticism was doubt about whether physical mechanisms could perform the many remarkable functions associated with life, such as complex adaptive behavior and reproduction. My friends at DNA. Unfortunately, these doubts have not been satisfied. How does the spider build that web? How do you account for that behavior? How does DNA transmit the ability to do this? The idea that all this is explained is itself a vast illusion. He goes on. With experience, on the other hand, physical explanation of the functions is not in question. The key is instead the conceptual point that the explanation of functions does not suffice for the explanation of experience. Again, the confusion. Physical explanation of the functions themselves, perception, cognition, language, is the question. In a similar way, he says, experience is disanalogous to the elan vital. The vital spirit was put forward as an explanatory posit in order to explain the relevant functions. It could therefore be discarded when those functions were explained without it. Experience is not an explanatory posit, but an explanandum in its own right. And so it is not a candidate for this sort of elimination. So he's trying to draw a difference between the hard problem of experience and the problem of explaining life. Now, who was the elan vital? Well, it was Bergson. There's his definition of the elan vital. So all organized beings, from the humblest to the highest, from the first origins of life to the time in which we are, and in all places as in all times, do but evidence a single impulsion, the inverse of the movement of matter, in other words, to increasing organization, and itself indivisible. So that vital spirit could therefore be discarded when those functions were explained without it. Schrödinger would not have agreed. Remember his book, What is Life? No laws of physics that can account for this. I guess Chalmers disagrees with Schrödinger. As the biologists, of course, they're all better physicists than Schrödinger. We have seen the problem of the transition of forms. There's evolution, whether it be from one form of beetle to the next. And the problem of common sense knowledge have the same base. Neither is solved. The problem of instinctual behavior, spiders, bird migration, amoebas, and the problem of action, the same base. Neither is solved. In effect, Dr. C is trying to dissociate the problem of life from the problem of experience. You cannot. Both problems are the same. Hint. This is why matter and memory was followed by creative evolution. So what have we seen? The problem of the origin of the image of the external world has been utterly obscured. Therefore, this concept is obscured, that we require a physics and a form of device within that physics that can support specification of an image of the external world. 2, a set of theorists, for example, Bloch, realized that some form of dynamics beyond computation seems to be needed. Again, a huge gap for them to leap. But failing to understand one, they cannot conceive why dynamics, that is chemicals, transmitters, electromagnetic fields, whatever that they can see in the brain, should yield consciousness. Why? Because they cannot conceive of the overall purpose of such a dynamics, namely our reconstructive wave. Chalmers, with zero appreciation of dynamics, veers towards a useless panpsychism to make it even worse. Thus, the conclusion, Bergson t-shirts are not popular. But they're not going to be available in Australia, for sure. So down the road, definitely current memory research in Bergson, and going to the bottom, their language comprehension. Bergson's radical model. These two we have to do for this series. Look at Chomsky's quote. It's an interesting question whether the functioning and evolution of the human mentality, and of course he's thinking language, can be accommodated within the framework of physical explanation, as presently conceived. Yes, we're going to see that. We're also going to talk Ned Block and access consciousness and Piaget's precedence here and his critique of Bergson, and we're going to use this as an interesting exercise in Bergson's theory and how it can easily embrace this. And other things on the list I've had: holographic principle in physics, time travel, temporal consciousness, QM's origin. And there's always something else. So next time, we'll see. Until then, signing off.